Yes friends, welcome once again to the class. Let's move on towards question number 2b of 2013 physics optional. Okay, so the question 2b says the following, that prove that as a result of an elastic collision of two particles under non-relativistic regime with equal masses. So two particles have actually equal masses and they are undergoing an elastic collision, and that is in a non-relativistic regime. What does it mean by non-relativistic regime? Non-relativistic regime simply means that there is no variation of mass with velocity. Okay, if the mass varies with velocity, then it is called relativistic regime. But under non-relativistic regime simply means that the mass is not varying with velocity. Okay, and those two particles actually have equal masses, so the scattering angle will be 90 degree. This is what we have to prove. Okay, the scattering angle, that is the after colliding they will scatter in different directions. So after collision, when they scatter in different directions, that scattering angle should be 90 degree. That's what we have to prove. Okay, and we have to illustrate this answer with the help of a vector diagram as well. Okay, so let us see how to solve this particular question. So actually there are no external forces acting on the two objects during the collision. Okay, so we have two objects with us. This is m1 mass object, and another object is also there. Its mass is also m1 only. Okay, so this is object 1, its mass is m1, and object 2, its mass is also m1 only. Okay, so what is the initial situation which we have with us? The object 1 with mass m1 is moving along the right side, that is along the I cap direction. Along the I cap direction it is moving, this m1 object, which is object number 1, along I cap it is moving, and its velocity is v1 comma I. Okay, where I stands for initial, the subscript I, this particular subscript I, it stands for what? Initial. It stands for initial. Okay, and what does it mean by 1 means object number 1. Similarly, when it collides with this, they are scattered in different directions. Okay, so m1 object, this object number 1, acquires the final velocity v1 comma f. Okay, so object number 1 has mass m1 only. Object number 1, it is velocity 1 comma f. Okay, means object 1 final velocity f. Okay, and again over here object number 2 final velocity f for final velocity. Okay, so this is the thing. So vector diagram is like this, and I will explain this particular vector diagram. You can have a look over here, that this angle from here till here, this particular angle, it is what? It is 90 degree. This particular angle is 90 degree. So that is the thing. So there are no external forces acting on the two objects during the collision. So during the collision there are no external forces acting on these two objects. Okay, the collision forces are all internal actually. Okay, so the collision forces over here, the collision forces are all internal at this particular point, because this m1 and this m1, that is object 1 and 2, they have together form a system. These objects 1 and 2 together form a system, and whenever they together form a system, no external force is acting on them from the outside. Okay, so if you consider 1 and 2 as the same system, then all the forces are internal actually. Whatever force 1 applies on 2 and whatever force 2 applies on 1, they are under the same system, because 1 and 2 are the same system. Okay, so that is the thing. Therefore momentum is constant. Collision forces are all internal, therefore momentum is conserved. Okay, momentum is constant, or you can say conserved. So initial momentum of the system is equal to final momentum of the system. P denotes momentum, I denotes initial, F denotes final, P again denotes momentum, SYS denotes system, SYS denotes system. And what does it mean by this symbol? You already know, it is the symbol of vector. And let us suppose this is your equation number 1. Let us suppose. Now what does it come up to be? See, why this becomes finally, if this is suppose your equation 1, then what does it become? Have a look at the initial momentum. The initial momentum will be m1 multiplied by this much, because only object 1 is moving initially. So initial momentum will be m1 multiplied by this, and object 2 is at rest initially. Initially object 2 is at rest. So the object number 1 mass is m1, object number 2 mass is m1, but this particular object is at rest. So this initial momentum will be m1 multiplied by v1 comma I. Okay, so you can have a look. m1 multiplied by vector v1 comma I. This is the initial momentum. Now let us look at the final momentum. So have a look. This is final momentum. m1 multiplied by mass into velocity is equal to momentum. So m1 multiplied by vector v1 comma f. This will be momentum of object 1, final momentum of object 1. And for object number 2, the final momentum will be m1 multiplied by v2 comma f. Okay. For object number 2, the final momentum is m1 into v2 comma f. This is very clear from here. Okay. So this becomes like this. Now suppose this is what? Equation 2. This was equation 1, and this becomes this much. This is what? This is equation 2. So from here, m1 and m1 cancel from both the sides. So you are left with v vector 1 comma I equal to v vector 1 comma f plus v vector 2 comma f. Okay. Let us suppose this is what? Let us suppose this is equation number 3. Okay. So the initial velocity which is a vector form, it is equal to the sum of the final two velocities. Okay. Vector sum I mean, not arithmetic sum, but we are talking about vector sum because vector symbol is existing over here. So this is suppose your equation 3. Then what happens? See, you will have to actually multiply this number by, you have to take the dot product actually. Okay. Now take the dot product of this particular entity with itself. Take the dot product of this entity with itself. Okay. So just imagine we write it one more time. Okay. Let us imagine we are writing this particular entity one more time suppose. So what will happen? So this is the thing. Okay. So this is what? This is again, once again I have written that. Now take the dot product term by term. Okay. Take the dot product term by term. So take dot product of this entity with this entity and this entity, that is dot product of that with itself. Okay. With this entity. So finally what do you get? Finally you will get something of this kind. So v1 comma I vector dot v1 comma I vector is equal to v1 comma f vector plus v2 comma f vector dot v1 comma f vector plus v2 comma f vector. So let us take the dot product term by term. So this dot product taken with this particular entity dot product taken with this. So this is the thing. Then this particular entity dot product taken with this. So this is the thing. Then this particular entity dot product taken with this. So this is the thing. Then this particular entity dot product taken with this. Then that is the thing. Okay. Now let us suppose this is what? Equation 4. Let us suppose this is equation 4. Now this dot product is commutative. Okay, this multiplied by this and this multiplied by this. Have a look. Both of them are dot product. So dot product is commutative. So we can write it to be 2 times. Okay. So this dot product of vector with itself will give you the magnitude square, because dot product is what? Dot product is actually scalar in nature. So as dot product is scalar in nature, so it will be v1 comma I square without the vector sign. Okay. So v1 comma I without the vector sign square. Similarly, this particular entity v1 comma f without the vector sign square. Okay. So v1 comma f without the vector sign square. Then what is over here? Have a look. v2 comma f without the vector sign. Okay. It will be v2 comma f square without the vector sign when you take the dot product. So it will be like this. And what about this particular entity? Dot product is commutative, so we can write it to be 2 times of this multiplied by this, means dot product. This dot did this 2 times. 2 times of this dot this. So 2 times of v1 comma f vector dot v2 comma f vector. Let us suppose this is what? Equation number 5. Let us suppose. So we have got one entity here. Now kinetic energy before and after the collision is the same. You already know. Now do not ever write. I have already told you in the lectures then that never write the fact that kinetic energy is conserved. You cannot write such things. Okay. Kinetic energy is conserved. You cannot write. Why you cannot write kinetic energy is conserved? You already know all those stuff. I have already told you in the lectures that kinetic energy is conserved. It is wrong to say so. You can only write kinetic energy before and after the collision is the same. That is the only thing which you can write. Okay. So have a look. So over here initial half m1 v1 comma I square. Okay. So it will be half mv square is the kinetic energy. So initial kinetic energy is half m1 v1 comma I square. Then what will be the final? final will be half m1 v1 comma f square. Okay, so where is it? Half m1 v1 comma f square. Okay, then half m1 v2 comma f square. Okay, so that is the final kinetic energy. So that is the thing which we have written. So half cancelled, half cancelled, half cancelled, m1 cancelled, m1 cancelled, m1 cancelled. Okay, so v1 comma I whole square is equal to v1 comma f square plus v2 comma f square. Okay, let us suppose this is what? Let us suppose this is your equation 6. Okay, now have a look at equation 5 and 6. Okay, so compare the equations 5 and 6. So after you compare this equation 5, okay, and after that you compare this equation 6, what do you get? What do you get? So you will find that this particular entity will be equal to 0. That's what you get when you compare 5 and 6. When you compare equation 5 and 6, this particular entity is equal to 0 is the thing which you get. Okay, so we have got v vector 1 comma f dot v vector 2 comma f equal to 0. You can have a look at equations 5 and 6 and you can compare yourself. Now v vector, the magnitude of this particular vector is not 0. This particular vector, its magnitude is non-zero. Non-zero magnitude. Then again this vector, what is the case? Non-zero magnitude. Okay. So as the magnitude is non-zero, what happens? If the magnitude is non-zero, still their dot product will be 0. That means the vectors are perpendicular. Because the dot product of two non-zero vectors is 0 only when they are perpendicular. The dot product of two non-zero vectors is 0 only when the two vectors are at right angles to each other. Okay. So this vector and this vector, what are they? 90 degrees to each other. So what is the thing? Therefore the scattering angle is actually 90 degree. Therefore the scattering angle is 90 degree. You can have a look. These two vectors make 90 degree angle with each other. What does it mean actually? Have a look. v1 comma f, v2 comma f. Okay, they are vectors. This vector is moving in this particular direction. This vector is moving in this particular direction. So the angle between them is 90 degrees. You can have a look. This direction is different. This direction is different. So what is the thing? Clearly, they are perpendicular. As they are perpendicular, so the scattering angle is 90 degree. From here till here, the angle is 90 degree. So if from this initial line of propagation, if you measure the angle, then this angle will be theta and this angle will be 90 minus theta. Okay, because from here till here the angle is theta. Okay, so the scattering angle is 90 degree. So in this way you can solve this particular question. Now this is what? This is your what we can say vector diagram. You can have a look. This is what is vector diagram. Okay, the direction of each velocity has been shown. The direction of each velocity has been shown. Okay, so I cap direction is this one, j cap direction is this one. So it is clearly shown over here. Okay, so that is the thing. So this was asked in the year 2013, paper 1, physics optional, UPSC. 2013 paper 1 physics optional, UPSC. So in this way you had to solve this particular question. Okay. Now we will move on towards question number 2C in the next class. In the next class we will move on towards question 2C. Now one playlist will appear over here. You can click on that playlist and watch the entire series. Thank you very much.